Welcome back to Unit 3 of Semester 1, still in Chapter 6, Section 6.2, Radical Expressions. Today's one and only goal is that you will be able to simplify radical expressions by the end of the lesson. So in order to simplify radical expressions, we need some properties, some powers. We've seen these properties before. They were always integer exponents. This time we're going to deal with rational exponents, which means they could be fractions or decimals. So product of powers, we've seen that before. A to the m times a to the n equals a to the m plus n. My example over here is 2 to the 1/2 times 2 to the 2/3 equals 2 to the 1/2 plus 2/3, or 2 to the 7/6. Power of a power, a to the m to the n equals a to the m times n. 2 to the 3rd times to the 3/4 power is multiplying together, or 1/4 power. 3/4 times 1/3 simplifies to 1/4. Power of a product, a times b to the m equals a to the m times b to the m. 3x to the 1/2 equals 3 to the 1/2 times x to the 1/2, or square root of 3 times square root of x. Negative exponent, negative a to the negative m equals 1 over a to the m. 4 to the negative 1/3 equals 1 over 4 to the 3rd, or 1 over the cube root of 4. Obviously, you would simplify that, get the radical out of the denominator, but this is just an example of how you would rewrite it. 0 exponent, a to the 0 equals 1. 1,000 to the 0 power is 1. That's right, anything to the 0 power is 1. Quotient of powers rule, a to the m divided by a to the n equals a to the m minus n. 2 to the 3/5 over 2 to the 1/5 equals 2 to the 3/5 minus 1/5, or 2 to the 2/5. And power of a quotient rule, a to the m, a over b to the m equals a to the m over b to the m. 2 over 3 to the 1/4 power equals 2 to the 1/4 over 3 to the 1/4. So it's the same rules we used before, just now we could have fractions for exponents. So real quick, let's go through some examples of how we might use this. 5 to the 1/3 times 7 to the 1/4. Well, there's a power outside. We can distribute that power to all the powers inside. 5 to the 1/3 times 3 times 7 to the 1/4 times 3, or 5 to the 1. 3 times 1/3 is 1 times 7 to the 3/4. Obviously, you can put this in your calculator to get a decimal. We're just practicing using the powers here, the power properties. 2 to the 3/4 times 2 to the 1/2, they have the same base, so we can add the exponents. 3/4 plus 1/2, we can add that in our calculator and get 2 to the 5/4. 2 to the 1/2 over 5 to the 1/2, with the power of 3 on the outside of the parentheses. We can distribute that to each of these exponents, and we get 20 to the 1/2 times 3 over 5 to the 1/2 times 3, or 20 to the 3/2 over 5 to the 3/2. And then, if I look, I can reverse this property. I can say 20 over 5. We've got 25. 20 over 5. And I can pull that 3/2 out because they have it on both, so that's reversing that property. And 20 divided by 5 is 4 to the 3/2 power. Right? Or square root of 4 to the 3rd power. Square root of 4 is 2 to the 3rd power, or 8. There's a lot going on there, but that's using all of our properties we've had so far. Okay, product property, this really goes right along with what we were just doing, because it's with radicals, but radicals really can be rewritten as exponents. So it's the same idea. The 4th root of 27 times the 4th root of 3 is really, because it's the same radical, we can do the 4th root of 27 times 3 of the one radical sign, or the 4th root of 181, or 3. Well, there's other ones for you to simplify on your own, but it's the same idea. You could also say 27 to the 1/4 times 3 to the 1/4, which is 27 times 3 to the 1/4, which would give us the same answer. So it's really, having these separate properties for radical signs, you can rewrite them as rational exponents and get the same result. Quotient property, same idea. We'll show you it's the same idea. If I have two fractions separated or together, I can put them back together as one fraction or separate them however I would like to do it. In this case, in A, there's separate fractions being divided. Since they have the same roots, I can do the cube root of 250 divided by 2, which is the cube root of 125, or the cube root of 125 is just 5. Remember, you could do 250 to the 1/3 divided by 2 to the 1/3. I can rewrite that as 250 divided by 2 all to the 1/3 power, which is just 125 to the 1/3 power, which is just 5. So same idea, we're just using it with radical expressions. You could try the remaining two examples if you'd like a little extra practice. Adding and subtracting radicals, if they have the same root and the same radicand, so cube root, third root, fifth root, then you can add and subtract them. When I said by them, you add what we call the coefficients. So in A, 2 5 roots of 10 plus 6 5 roots of 10, they both have fifth roots of 10, so I can do 2 plus 8 or 6. Get myself there. 2 plus 6 fifth roots of 10, which is just 8 fifth roots of 10. What if they don't have the same root? Let's look at letter B. They don't have the same root. Like, for instance, the fifth root, or the third root of 5 plus the third root of 40. Well, can we break this down at all? Can we break it down? Can we find any way to find perfect cubes that divide 40? Well, it's like perfect squares. Remember, in the previous chapter, we did a list of perfect squares. Whatever power or root you have, you can make a list of perfect nth roots. In this case, we're going to make a list of perfect third roots. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and I don't even have to go over for this problem because it's 40. 40 would be between 64 and 27. 27 doesn't divide 40, but 8 does. 8 times 5 is 40, so I can rewrite this problem as cube root of 5 plus the cube root of 8 times the cube root of 5. Why would I do that? The cube root of 8, well, that's just 2. So 1 cube root of 5 plus 2 cube roots of 5 equals 3 cube roots of 5. So if they don't have the same radicand, the number under the radical sign, under the root sign, try and make a list of perfect nth roots and see if any of them can divide them out, simplify, and then be able to add or subtract. I'll leave C for you. 2 minus 5 would be negative 3 cube roots of 8. Excuse me, fifth roots of 8. Okay, last thing on our docket for today, simplifying variable expressions. We'll just do a couple of these and then we'll practice more in class tomorrow. If I have a bunch of stuff underneath the radical sign, the way I try and do it is I try and separate, just like we do with square roots. It's cube root of 27 times the cube root of x to the 9th. And then I would look at this and say, okay, the cube root of 27, can I put that in my calculator? Does it come out nice? Is it a perfect root? Math. If I go down to 4, it's cube root. Math. 4. Cube root of 27. Could make a list of perfect perfect cubes, which we did on the last slide. That's 3. So this is really 3 times, well, the cube root of x to the 9th. That's really x to the 9 over 3, or 3 times x to the 3rd. That's how I would simplify using that. B, the 5th root of x to the 10th. That'd be like x to the 10 over 5 divided by y to the 5 over 5, or x squared over y. Okay? Fractions. Fractions, if you have fractions, what can we do? Dividing them, we subtract the exponents from top to bottom. 6 divided by 3 is 2. X to 1 over x to the 1/2 would be x to the 1 minus 1/2 times y to the 3/4 over, or minus 1/2. If we simplify this, we get 2x to the 1/2 times y to the 1/4. You can write those as root 4 through to y, square root of x. You can write that out as well. Last one, this is like number 55 in your book. What if I have two separate roots? Well, I would multiply them together on 1 because they're both square roots. X to the 3 plus 2 is 5. Y doesn't have anything to multiply by. Z cubed times z to the 5th would be z to the 8th. That's all being square rooted. So we'll leave the 2 there. So at this point, I would separate them again. The square root of x to the 5th. The square root of y, the square root of z to the 8th. They're all being multiplied together. Here's the trick. If they're even, it's real easy. Okay? If they're even, they're variables. You just divide them. When the square roots divide what we have. So really, this is z to the 8 over 2, which is just z to the 4. Square root of y, nothing I can do with that. So that's going to be square root of y when we're done. Square root of x to the 5th. If it's an odd power, and we're square rooting it, we say x to the 4th times x. And why do I do that? Because then we get the square root of x to the 4th times the square root of x, which the x to the 4 over 2 times the square root of x times the square root of y times z. When we put that all together, we get x squared times z. X and y are both being square rooted. They can go over underneath one side, and that's so did we hit our target today? And I think we did. I think we're going to be able to simplify radical expressions. Make sure you have all your notes tomorrow in class. We will be going over this together. So make sure you're ready to go. Show your notes, and we'll practice, practice, practice. Have a good evening.